In this learning objective, I'm going to show you an algebraic way of telling how many solutions there are to a system without graphing them. Back in section 1, though, we graphed them and we said, well, if we graph them, the two lines and they look like that parallel, there's no solution because they don't cross. If we graph them and they intersect in one point, there's one solution. Another one is if we graph it and then we graph the other line and it's right smack dab on top of it, it crosses it and there's infinitely many solutions because all these ordered pairs are going to pop off. Well, you don't have to graph these and you can figure it out. So let me show you. Let's use a linear combination to solve this equation. Remember, we want the same number but opposite signs. I'm going to, first of all, notice this. Be careful, they're not lined up. My x's and y's are not in order, so I need to first rewrite this because I almost screwed it up. 3x minus 2y equals 5. And then negative 6x plus 4y equals 7. Now I'm going to choose to get rid of x's or y's. It doesn't really matter in this case. To make these the same number, how about a 6? So I'm going to take the first equation and times it by 2. So that'll give me a 6x minus 4y equals 10. And then down here we have the negative 6x plus 4y equals 7. If you add down, here's what happens. 6x minus 6x is 0. Negative 4y plus 4y is 0. 10 plus 7 is 17. It ends up saying 0 equals 17. First issue I have is my x's and y's both fell out. I have no idea what the value is of either of those two variables, so I can't solve for x or y. But here's what it told me. It gave me a final answer. It said, hey, 0 equals 17. I look at that and I say, you're absolutely wrong. 0 is not 17. 0 equals 0. Or 17 equals 17. That is true. 0 doesn't equal 17. So this actually is a special case. When the x and y's falls out and you get just the numbers back, you have to decide if it means no solution or infinitely many. It is either mimicking parallel lines or it's mimicking that the two lines fall on top of each other. If this algebraic statement is false, it means there is no solution whatsoever. If you were to graph these two lines, they would actually be parallel. Let's take a look at this one. Now the variables are lined up, so that's great. I'm going to try to get rid of the y's this time. I want opposite signs, which they are, but the same number. So I have a 20. I can make that top equation a 20 by multiplying by a 5. New equation will be negative 10x minus 20y equals 10. And then 10x plus 20y equals negative 10. If I add down, negative 10x plus 10x is 0. Negative 20y plus 20y is 0. 10 minus 10 is 0. What I'm left with is 0 equals 0. Again, it's a special case. The variables are gone, so it's either infinitely many or no solutions. Well, does 0 equal 0? Sure, it does. Which means that's a true statement, so the answer here is there are infinitely many solutions. What that means is if I were to graph these two equations, you would see that they actually fall right smack dab on top of each other.